In this video, we're going to start talking about vector operations in MATLAB. You've probably seen vectors using the help system to look up different functions, and at this point, it's time to really get comfortable with them because they're fundamental to using MATLAB. Our objectives here are to define the term vector in the context of MATLAB. We want to learn multiple commands for creating vectors, learn how to access and manipulate specific elements in a vector, and we'll introduce some common built-in functions that are designed to work with vectors, and then just expand our understanding of earlier concepts such as entering mathematical expressions and writing user-defined functions, expand those to include working with vectors. So what is a vector? So far we've been working with scalar variables where we assign a single number to a variable. In fact, multiple numbers can be assigned to a single variable. This is a vector. This is in contrast to a vector in science and math where we say it has some magnitude and some direction. That's a vector in math. In MATLAB, a vector is simply a list of numbers assigned to a single variable. So here we have an example. This variable a has the numbers 1, 1, 2, 3, 5, and 8 all assigned to a. So instead of just a single scalar, a has 6 numbers, or we would say a has 6 elements. So each of these numbers is an element, and we would say, for example, this number 2 here is the third element in the vector A, and so that number 3, it's the third element, and we would say that that has an index of 3. So this vector A that we have here as an example, as our first example, this is called a row vector, simply because the list of numbers stored in the variable A are stored in a row. The way that we enter that vector is with these square brackets, and the numbers are separated by spaces or commas for a row vector. We can also create a column vector. So B here is a column vector, and a column vector is defined when the elements in the vector are separated by semicolons. That's what makes this a column vector. So the vector B is a column vector. We can switch back and forth between a column or a row for a vector using what's called the transpose operator, and that's simply an apostrophe. It's called the transpose operator. So we can see I've created these two vectors A and B, and then the transpose of B is B row, and they show up in the workspace, and now we have more information that's useful in the workspace. We can see the values in the workspace, the minimum value, the maximum value, and again the workspace is there to help us keep track of what's going on in our MATLAB session. So one way to create vectors is just to enter in the numbers like this. Oftentimes we want to create a vector of evenly spaced numbers. So for example, evenly spaced numbers between 10 and 50 spaced by 10. We can type that in, although typing that in would get cumbersome for say 100 numbers. That'd be a lot of typing. So another way to do that, MATLAB has a built-in function called the linspace function. That's short for linear space. And for that function, we have the start value as the first input, the stop value as the last input, and 5 would be the number of elements. So you could read that as saying create create a vector x with 5 elements starting at 10 and ending at 50. Another way to create an evenly spaced vector is with the colon operator. And the colon operator just gives us a way to create a vector using slightly different input information. Here we use the start, and we have the stop, but instead of telling it how many elements we want in the vector, we're going to specify in the middle here an increment. So the colon operator, this third way of creating this vector, is different because it's saying create a vector x that starts, its first element is 10, its last element is 50, and we're going to increment by 10, or in other words, the adjacent elements are spaced by 10. So once we've created vectors, now that we know how to create vectors, let's look at how they work in mathematical operations. We're going to focus now on element by element operations. In other words, we want to, when we do some math, we want it to work element by element. So as an example here, here's two vectors x and y, and let's say we want to calculate x plus y. And so we see to calculate x plus y, we just type in x plus y. And our result gives us a new vector, x plus y, where that first element of x plus y is equal to the first element of x plus the first element of y. That goes there. The second element of x plus y, the 3, is equal to the second element of x plus the second element of y, and so on. And so it adds the corresponding elements in the vectors and creates a new vector with that sum. One important note here, for that to work, those vectors must be the same lengths. That works for addition and subtraction. One thing that we have to be careful about is multiplication and division. So for multiplication, if we just use the same multiplication sign that we've been using for scalars, you'll get this error, and this error telling us inner matrix dimensions must agree. That's because the asterisk for multiplication, it defaults to matrix multiplication. Now, unless you're in Math 260, linear algebra, you're probably not that familiar with matrix multiplication. We will actually talk about it later on in the quarter, but for now, we're going to focus on element by element operations. And to do element by element operations, or element by element multiplication, or division, or exponentiation, the way that you tell MATLAB you want to do that is with this period. So you put a period before the operator. So if we put a period there, now x times y gives us the first element of x times the first element of y, which is equal to 1. The second element of x times the second element of y, which is equal to 2. The third element of x times the third element of y, which is 2 times 3, which is equal to 6, and so on. So we can do that the same for division and exponentiation. So here we have for exponentiation again, there's that period to do this element by element. Now I didn't use the period for the division because in this case we are dividing by a scalar. And if we're dividing or multiplying by a scalar, we don't need the period. But one thing that's important to note is it doesn't hurt to put the period there anyways. We wouldn't get an error if we had a period right before that division operator right there. MATLAB would not give us an error, and then we'd just be playing it safe. So two keys when doing math with vectors. One is you need to make sure the vectors are the same lengths, and two is we need to have a period for multiplication, division, and exponentiation right before the operator, because the MATLAB defaults are matrix operations, and you'll get an error otherwise. So now I think you hopefully get an idea of how to expand our work before with mathematical expressions to work with vectors. Let's look at how we might access specific elements inside a vector. So here's that vector A again, and let's say we want to just pull out the third element of A. We can do that by putting the index 3. We call that the index, and we just do that in parentheses. So you can read this command as take the third element of A and assign that to a new variable that we called third. There's a special one for the last element that uses the keyword end. So the end, that's a key MATLAB keyword, and that always means the last element in the array when you use it in an index. So we can use that to access the last element. We can also use indexing to get groups of elements. So here we say, you could read this as take the second through second to last, or n minus 1, element of A and assign that to a new vector middle. So now middle is a new vector that just includes those middle 4 elements of A. What's actually happening here is we're creating an evenly spaced vector, so that that command to end minus 1, so let's just look at that command for a minute, in parentheses. End, in this case, is the keyword. That's going to be, since A has 6 elements, end is going to be 6. So this is, as MATLAB evaluates this, this is actually 2 to 5. So 6 minus 1, 2 to 5, which is using the colon operator to create an equally spaced vector with the default increment 1. So it's actually a vector in here, 2, 3, 4, 5, and then taking the second, third, fourth, and fifth elements of the vector A and assigning those over to the new variable middle. So we can really do any type of expression that we want inside the parentheses to be very efficient with how we're accessing vector elements for whatever use we might use them in solving the problem. Another thing we can do when we're accessing vector elements is we can use relational operators, which we haven't really talked about. So we have relational operators in MATLAB: greater than, less than, greater than or equal to, less than or equal to. In this case, we're using the greater than operator, and we're saying take all of the elements of A. What this is saying is, first of all, the elements of A that are greater than 2. And now this command says take all of the elements of A that are greater than 2. That's what this does. We take the elements of A greater than 2 and then assign them to a new variable called GT2, or that's short for greater than 2. And so those elements are the 3, the 5, and the 8. So that creates a new 3-element array, GT2. So that's how we can access specific vector elements. One thing that kind of makes this a little bit more powerful is we can use some of these strategies to manipulate a vector that exists. So again, here's that vector A, and let's say we want to just delete an element. So empty brackets will delete an element. So in this case, we're going to delete the first element, because we've said A1 is equal to empty brackets, and that deletes the first element. Another thing we can do is add an element to a vector. So here we say A n plus 1, so we're making that vector one element longer, that's equal to an plus an minus 1. And so what we've done now is we've added one additional element. And we can add more than one element, just depending on what we're doing on this assignment here. On that assignment on the right-hand side, that determines what we're going to add, and here's how many elements of A that we're working on. In this case, this is only one element. Another thing we can do is manipulate elements of A that meet some certain condition. So here's another relational operator, this time less than or equal to. And here we're saying take the elements of A that are less than or equal to 3 and set those equal to 0. So the first three elements of A, these are all less than or equal to 3, so we set to 0. Okay, so let's look at some built-in functions that work with vectors. One common function that you'll use a lot is the length function. This basically counts the number of elements in a vector. We have the mean function. This finds the average. So this would be equal to the sum, which is another built-in function, of A divided by the length of A. That's equal to the mean of A. So these functions are related. I don't have the sum function on this slide, but that's another function that's available. Also, the max function finds the largest element in A. The min function would find the smallest element in A. So those are other functions. And you can use the MATLAB help for more info on these. A few more functions. We have the sort function. So here we have a new vector B, and the sort function will rearrange the elements in order from smallest to largest. The find function finds the indices. This returns the indices of the elements that meet the condition in the input. So in this case, the input is find all the elements of B that are greater than 0. And what it's telling us is the second, third, and fourth elements of B are greater than 0. Another example use of the find function, just introducing another relational operator. The double equal sign, this is relational equals. That's because we have that separate one because the single equals means assignment, as we talked about. So this says find all of the elements in B that are equal to the round of B, which tells us that's only true if those elements are an integer. So elements 1, 2, and 3 are all integers, is what that command would tell us. Another function that's also useful for creating vectors is the ones function. If you want to create a vector that's all the same number, you can just multiply that number times the ones function. And in this case, if we want a row vector, we'll talk about matrices later, but this is how many rows and how many columns of ones are you going to make. We're talking about vectors right now, so we're either going to have one row and a number of columns, or one column and a number of rows. Let's talk about writing functions for vectors. Some guidelines just based on what we've talked about. One is we want to make sure that we're using those periods, so period times, period divide, and period exponentiation, so that we can do, when we're intending to do element by element operations. When we're writing a function that works with vectors, we want to make sure we document any limitations on the vector inputs in the help comments for the function, so it's clear how to use the function. In general, we want to write a function if it's working with a vector that will be able to use any length vector, so that length built-in function can be handy for that, so we can write our function in general terms. Also, the end keyword is also useful, so it works with any length vector, and when we're using that to reference elements near the end of a vector. So that concludes this introduction to vectors. We'll get more practice with this in a self-assessment and in the videos to follow.